Okay, so P 3.1, energy demand. Now, what this topic is about your energy resources. So, where do we get our energy from? What are the issues with the different sources of energy? So, the first thing I'm going to show you is a pie chart that shows you where we get our energy from. So, I think it's really important that we know what percentages we're talking about here, because some things are large percentages and some things less so. So, that's my circle for my pie chart, and I'm going to split it into thirds. Now, roughly 1/3, so 31%, is made up of coal. Another third is made up of oil, and then it gets split up into some smaller sections. Now, my pie chart's not quite to scale there, so I'll just take a little bit off this one. There we go. And this one now splits up into a couple of other ones. Okay, so this one here is about 24%. So I'm looking for about a quarter. So that is roughly a quarter, and that is gas. Now, if you look, these ones are all fossil fuels. Okay, so oil, coal, gas. Those ones are all fossil fuels, and look how much of that circle is all being taken up by fossil fuels. So 24% here. So in terms of fossil fuels, it's 31 add 24, so 62, 85, 86. So 86% of the world's energy is provided by fossil fuels. So anybody that says anything that doesn't address fossil fuels is not talking about energy demands. They're talking about some small sliver. It's how do we reduce that amount, because that is way too high a percentage currently, and we'll explain why later on. So our other choices are here, which are nuclear, which is 4%. Hydro, which is rivers and dams, which is 7%. Now, nearly every single river that is suitable to be turned into hydroelectric power has been, so that's pretty much maxed out now. The only one that's new that might happen is tidal barrages or wave power, which we'll come on to later. Those two might increase, but in terms of rivers and dams, it can be done, it has been done. And then the last one is other, which is 3%. So that's things like solar panels, wind turbines, solar furnaces. Absolutely tiny percentage of the world's energy comes from those things. So really, we've got to sort out fossil fuels. 86%. Okay, so part of that 3% of the other is one called biofuels. So I'm going to skip those because I don't think that they're the most important thing that you can do just yet. So what we'll do first is we'll have a look at some of the issues to do with fossil fuels in particular very quickly. Okay, so the first thing you need to know about fossil fuels is that they are non-renewable. Which means that once you've used them, they run out. So if you look, 86% of the fuel that we currently use in the world, once we've burnt it, we're not making any more. So it will run out at some point. The only question is when. Okay. And the next thing you need to know about fossil fuels is that they emit CO2. And from the P2 module on infrared radiation, you learned that CO2 increases the greenhouse effect. which in turn leads to global warming. So they're the two key points. This isn't a module on fossil fuels, so I don't want to spend too long on it. But I think unless you talk about those two aspects of it, firstly, it will run out. It's non-renewable. It takes millions of years to make fossil fuels. We're burning them up in seconds. Secondly, they emit CO2. CO2 increases greenhouse effect and leads to global warming. If you don't understand those issues, then this pie chart lacks its impact, and people won't do enough to increase these three if they don't understand fossil fuels. So let's talk about one of the alternatives. Okay, so let's talk about nuclear to start with. And again, this isn't a module on nuclear power, so I won't go into too much detail, but just to give you the basics. You get the energy from unstable nucleuses. And there's two sources, either uranium or plutonium. And it's great because there's no CO2, so fall back to this, which means there's no impact on the greenhouse effect, but it does have two major problems. The two major problems are radioactive waste is expensive to deal with, okay. Now people always get worked up about radioactive waste, saying it's going to be really dangerous and it's going to last for thousands of years, both of which is true, but both of which can be solved if you spend the money correctly in terms of storing it. The problem with radioactive waste is that it's very expensive to process, which makes the actual energy expensive. And equally, we have some safety concerns. And again, you can make a nuclear power plant completely safe. The problem is that making it safe is expensive. If you look at Fukushima, for example, if they'd have invested more in their water pumps and their robustness to tsunamis, they wouldn't have been an issue. But the problem is that people don't. They cut corners in order to cut costs, and that's when we have problems. So, and the other thing we need to remember is that this is fission, which means splitting nucleus, okay, which you need to know later on. Okay, so the type of nuclear power we're talking about here is fission. We can't do fusion. If we could do fusion, it would solve both of those two, but we can't, not yet. And we'll talk about fission and fusion in more detail in the nuclear module. Okay, the next one I want to talk to you about is one called biofuels. Now, biofuels can be brilliant or can be terrible, depends on how they're done. So, it's any living, so bio means living, fuel, okay, bio, living. So, you're talking about plants, wood, animal, okay, and what you do is use it like a normal fossil fuel. You burn it to boil water, and then the idea is that you can plant more. So this one is renewable if you plant more. And when biofuels are at their best is if these three come from waste. Okay. So sometimes if you run a farm, for example, you could use your animal waste to make a biofuel generator and just burn pig poo, for example. That would work. Equally, if you in an industry where you produce a lot of wood waste, you could use that. Again, plant waste, so like all the husks from the corn which you don't need, you just wanted the corn, you could use that. The problem is when you chop down fresh trees and full mature trees in order to burn them, then it takes a long time for them to grow back, and it damages the ecosystem, and it releases a lot of CO2 that was stored in that wood and isn't adequately replaced. So sometimes you've got to be careful. Not all biofuel is good. Most of it is. So, and because you replant it, it is something called carbon neutral. And what that means is, it means that CO2 goes in when it's growing, but then that same CO2 goes out when it's burnt. Okay? So you've got CO2 going in when it's growing, and you've got CO2 coming out when it's burnt, and the two cancel each other out. So overall, no increase in CO2. Okay, and that's what carbon neutral means. And that's good for global warming, because if you're taking CO2 out of the atmosphere and then releasing it back into the atmosphere, overall it has no effect on global warming, provided you plant more. If you don't plant more, then it's not carbon neutral. You just burn it in plants, and that's CO2 out. So you've got to be growing more. These two have to cancel each other out. And the other problem with biofuels, and this is more when it's done on a large scale industrially, is biofuels such as sugarcane for cars. If you want to make fuel for cars out of biofuel, then the problem with that is it competes with food crops. So food prices increase. And I'm going to put a little caveat there. It's only some biofuels. Some biofuels compete with food crops, so the food prices increase. So mostly good, but some issues. Let's just summarise. Bio means living, so it's energy that comes from plants and animals. Best if it comes from a waste product, because then that's a double whammy. You're saving on waste and you're not using up something that would have been used for something else. It is renewable if you plant more. It's carbon neutral if you plant more. So CO2 going in when it's growing is the same as the CO2 that goes out when it's burned. So which means that overall there is no increase in CO2. Some biofuels compete with food crops, so food prices increase. And that's another disadvantage that you just need to take into account when you're growing the crops on a large scale. And the best example I can think of for that is sugarcane for cars to make bioethanol.